Hi Precalculus class, this is Mrs. Theiler. Okay, this is a monumental moment because you're part of the technology era now with me. So I'm going to teach you lesson 5.3 notes because I'm not there and I just felt it would be too difficult for the sub. So our objective today is we are doing unit circle trigonometry. I know that you've studied some of this last year in advanced algebra, so it will be somewhat repetitious. All right, we've got the unit circle is a circle of radius 1 centered at the origin. We've got it drawn here below, so since this is a radius of 1, the ordered pair up here is 0, 1. The ordered pair down here is 1, 0. The ordered pair out here, -1, 0, and the ordered pair below, 0, -1. Okay, then, radius of 1, unit circle, centered at the origin. We're going to draw an angle in standard position that terminates in the first quadrant, and we're going to label the angle theta. So here's the initial side, here's the terminal side. Our angle in standard position then is theta. So theta is just a variable that is generally used to represent an angle measure. I mean, x is a variable, m is a variable. They generally just use this Greek letter theta to represent angle measures. Okay, then this terminal side intersects the circle at an ordered pair, and the ordered pair, we're going to call it x, y. So it's just a point on the circle. Okay, then we're going to drop down and make a right triangle in the circle. So drop down the leg and it'll form a right triangle. Okay, so I'm going to highlight. I actually brought a little color so hopefully you guys can see this okay. You've got a right triangle in here whose angle is theta, and this leg is x because it's the ordered pair x on the circle, so we've got a leg x, we've got a leg y, and we know that the hypotenuse of this triangle is 1 because it's the radius of our unit circle. Okay, so knowing these right triangle in here, we've got a leg x, a leg y, and a radius of 1. We can use this right triangle trigonometry and also what we learned yesterday in 5.2, and we can write these trig ratios with reference to the unit circle. Using this, you can determine all the values of the 6 trig ratios using the unit circle and some reference angles. So sine of theta, sine is opposite over hypotenuse, so opposite is going to be y over 1. Or if I simplify that ratio, because we always simplify fractions, sine of theta is the y coordinate on the unit circle. Cosine of x is adjacent over hypotenuse, so it's x over 1, or simplifies just to an x. So sine of an angle is equal to the y coordinate, cosine of the angle is equal to the x value. Tangent is opposite over adjacent, so tangent of the angle is the ratio y over x. Okay, here's our reciprocal partners, which we learned yesterday as well. So sine of theta is then the reciprocal of y over 1, or 1 divided by y. Okay, secant of theta is the reciprocal, so 1 over x. And cotangent of theta is going to be x over y. Okay, hopefully you guys can see this okay. I know that it's kind of zoomed out. If we zoomed in more, then the quality got more intense and we were concerned about the uploading of that file. So, you know, move up or do whatever so you can see. Okay, so we've got tangent and cotangent, reciprocal partners there. Alrighty. Now, talking about special right triangles. Again, you've had these before. The special right triangles are your 30, 60, 90, your 45, 45, 90. Mr. Olson likes to call them the My Little Buddies. I call them sometimes like the tools in your toolbox. We are going to use these triangles a lot. So here are the sides of your 30, 60, 90 triangle. The leg opposite of 30, The leg opposite of 60 is square root of 3, and the hypotenuse across from the 90 is 2. Now you could change these ratios, but this is the most simplified version. Okay, 45, 45, 90 is, here's your right angle, a leg of 1, a leg of 1, and then the hypotenuse is square root of 2. Good, square root of 2. Can you see that? All right, let's go back up to the unit circle. I just want to talk about the quadrants and the positive and negative values in a quadrant. So, in the quadrants, in the first quadrant, you have ordered pairs, and the ordered pairs in the first quadrant are positive, comma, positive. In the second quadrant, your ordered pairs have a negative x value but a positive y value. In the third quadrant, you have a negative x and a negative y. And in the fourth quadrant, you have a positive x and a negative y. Okay, so this is going to help us talk about whether the trig ratios are positive or negative depending upon the angle measure that puts us into the appropriate quadrants. All right, we're going to go through and you're going to be able to use this information using the 30, 60, 90s in here, our quadrantal angles in these ratios to help us figure out trig ratios of angles that have reference angles of 30, 60, and 45 or are actually quadrantal angles. Now I'm going to come back to this little mnemonic device, the all soup turns cold, just in a little bit on the other side. Actually, what I would encourage us to do is rip this paper apart because we're going to keep coming back to this at the same time. So go ahead and rip your notes apart. You can restaple them later. All right, the first question is we are going to use the unit circle to find each of the values below. Now, each of these angle measures in here are quadrantal angles. Remember, quadrantal angles are those angles that land right on the axes. Okay, so what we're finding are the ratios. So the answers to each of these questions, the answer is a ratio. All right, so I'm going to want to know what is the ratio or what is the answer for cosine of 90. The answer is the ratio. Okay, looking at my unit circle back over here, 90 degrees is right up here because it's positive, so I go counterclockwise. At this location, the cosine value is equal to the x coordinate. Cosine is equal to x. So at this place, it's just the x value. Well, at 90 degrees, what is the x value? The x value is 0. So cosine of 90 degrees is equal to a ratio of 0. I mean, it'd be 0 over 1, but we would just simplify that to, that would be 0 over 1, so we just simplify it to 0. Okay, so the answer right there is 0. Okay, cosecant of negative 270 degrees. Okay, so here's our quadrantal angle, negative 270. Starting at our initial side, 0, going backwards, because it's negative, clockwise, right there is negative 270 degrees. Cosecant, according to these ratios, cosecant is 1 divided by y. So I'm going to write that down. Cosecant is the ratio of 1 divided by y. At this location, the y value is 1. The ordered pair right here is 1. So this would be equal to 1 over 1, which equals 1. Okay, secant of 90. 90 degrees, quadrantal angle, starts at the initial side, positive 90. Okay, then secant, looking at my ratios right here, my ratio for secant is equal to 1 over x. 1 over x. It's the reciprocal of cosine. Cosine is x, so 1 over x. At this particular location, the x value is 0. So we're talking about 1 over 0, which you know you can't divide by 0, so that's undefined. Okay, let's just do one more off here on the side. Let's do part D, because I want to. Let's do tangent of 180 degrees, okay? Tangent of 180 degrees. So tangent is the ratio of the y-coordinate divided by the x-coordinate. Let me write that down. So positive 180 degrees, right there, It's the y coordinate divided by the x coordinate. So in this case, the y value is 0 divided by the x value is -1, which simplifies to 0. 0 divided by any number is 0. Okay, so that's how you handle quadrantal angle ratios. And then you look at the ordered pairs and you just fill them in. Okay, now here's a little thing that I helped to memorize the cosine and sine, because really everything else kind of just falls after that. It's basically alphabetical order. Cosine is closer in the alphabet than sine. C comes before S in the alphabet. X comes before Y. So that's kind of how I remember that. Cosine goes with X, sine goes with Y. Okay, let me just check the time. Okay, great. All right, now we're going to talk about what happens if the angle is not, a quadrantal angle. It's actually an angle that lands inside of a quadrant. However, we're making them specific angles that have reference angles that are either reference angle of 30, 60, or 45, so we can use our special right triangles. So to find the values of most trig ratios in the unit circle, you need to do the following. Determine which quadrant the angle falls in. This will help you determine whether the answer is positive or negative. Okay, so here's the acronym all soup turns cold. All means all trig ratios that the terminal side lands in the first quadrant, those ratios are going to be positive. So every trig ratio, if I ask you the angle, and the angle is in the first quadrant, the A, just means all trig ratios are positive. Okay, everything is positive in the first quadrant. Well, you can see that because it's positive, positive. Okay, the S, the soup part. The S stands for actually sine. The S stands for sine. I'm going to rip this apart. Okay, so the S stands for sine. Maybe you can see that better. So the S is for sine. So what that means is the only trig ratios that are positive are your sines. If you're taking sine of an angle and that angle is in the second quadrant, then that ratio is going to be positive. Now also over here, I would add this to the little bubble, reciprocal. This table shows which trig ratios are positive. It also shows you their reciprocal partners have the same sign. So not only are the ratios of sine and cosecant is the reciprocal partner, so cosecant angles are also going to be positive as long as the terminal side lands in the second quadrant. Okay, the terms is T. That means tangent. Tangent are your positive values in the third quadrant. So if your terminal side lands in the third quadrant and we're taking tangent of it, that means your ratio is going to be positive. Every other answer is going to be negative. Also, the only other one, though, is its reciprocal partner, cotangent. Okay, the C, the cold, stands for cosine. So any cosine angle at which the angle lands in the fourth quadrant, those values are going to be positive. So this all soup turns cold helps you identify which ratios are positive. Now, obviously, if it's not positive, then it must be negative. Okay, I'll keep referring back to this. Determine your reference angles, and we're going to look at the special right triangle to help us get the correct ratio. So the reference angles in the triangles are going to get us our reference angles. All right, let's just try an example, okay? Okay, keep this, probably want to keep this out, okay? Or another good thing, let me show you what I would do on my worksheet. If you don't want to have this out, you certainly can. The other thing a lot of times I'll do when I'm doing these kind of problems, right at the top of my worksheet, I'll draw the 30, 60, 90 triangle, and I'll also draw, just to remind myself of, I'll just go this, all soup turns cold. Okay? Also, I'll draw usually at the top of my paper when I'm doing these kind of problems. I'll just redraw my 30, 60, 90 triangle. 30, 60, 1, 2, square root of 3. Okay, that's square root of 3. 1 is across there. And then your 45, 45, 90 triangle. Again, you don't have to put them. You can just look back there. 1, 1, square root of 2. So when we take this quiz next week, Tuesday, these are things that I would put definitely at the top of my quiz, 100% for sure. The other thing I would put on the top of my quiz is the unit circle and those ordered pairs that go with that. You've got, 1 comma 0, 0 comma negative 1 comma 0, and 0 negative 1. Good? Okay, now notice all of these angles are not quadrantal angles. All of these angles are not quadrantal angles. If you're identifying ratios for non-quadrantal angles, that's when you have to use reference angles and the all soup turns cold. Okay, so I've got the most important stuff on the top of my paper, so now I don't have to keep flipping around. Okay, answers are going to be ratios. Okay, and we're doing all of this without a calculator. All right, so 135 degrees. Which quadrant is 135 degrees in? The terminal side. Well, I start here and I go positive, 0. 135 would get us right in the second quadrant. Okay, that will tell us whether our answer is positive or negative. So if I'm a terminal side in the second quadrant, is cosine ratio a positive or negative? Okay, looking at the all soup turns cold, the only ratios that are positive are sine and its reciprocal partner cosecant. So since I'm talking about cosine and sine is the only one positive, I know that my ratio is going to be negative. So my answer is going to be negative. Okay, the next thing we have to do is reference angle. Reference angle. If I'm at 135 degrees, so maybe you need to draw this. Maybe you're not completely strong yet with your reference angles. 135 degrees. Here it is. Here it is. Right? There's my terminal side for 135 degrees. Right here is the reference angle. How many degrees is it positive, the closest, from the terminal side to the x-axis? 45 degrees. So we have a reference angle of 45 degrees. All right, now we're ready to start talking about our ratio. So you look at your 45, 45, and 90 triangle. Cosine is adjacent. It doesn't matter which 45 you look at. Cosine is adjacent over hypotenuse. So the ratio is going to be 1 over the square root of 2, and you never leave a radical on the bottom because the radical emperor says so. So we're going to multiply by square root of 2 over square root of 2, so you get square root of 2 over 2. Now, that's not your boxed answer, because remember, we said the ratio, since the terminal side is in the second quadrant, that ratio for cosine has to be negative. Now you can box it. Okay, let's try another one. Sine of 225. Okay, 225 degrees, moving in the positive direction, counterclockwise, 90, 180, 225, right there in the third quadrant. So we have a third quadrant terminal side now. We have a third quadrant angle. In the third quadrant, what's the only trig ratios that are positive? Tangent. Okay, and its reciprocal partner, cotangent. So sine is going to be negative. Okay, reference angle. Reference angle is going to be, if you start here, 90, 180, 270, here's our terminal side, 225. Reference angle is the shortest distance from the terminal side to the x-axis. So 225, little scratch work over here for my reference angle, 225 minus 180 gives us a reference angle of 45. Guys, all of your reference angles are going to be 30s, 60s, or 45s. Because if I don't give you those angles, you can't use your special right triangles. Okay, so we have a reference angle then, again, equal to 45 degrees. Okay, so using your little buddy here, your toolbox, sine of 45. So I'm taking sine of this angle. Even though it's sine of 225, they have the same ratio. The only difference is this one's in sine of 45 is in the first. We're talking about sine of 225. Reference angle is the same, so the ratio is the same. Sine of 45, sine is opposite over hypotenuse. So we have 1 over square root of 2. Multiply top and bottom by square root of 2 over square root of 2. So we have square root of 2 over 2, and the ratio then is negative. Okay, my bell just rang for me to go to class. So I'm going to go through these a little quicker. I still got 5 minutes. It's okay. So sorry if I'm speeding up. Remember, you can always go back and play it again. I guess that's the beauty of video. Okay, negative 60 degrees. Negative 60 degrees goes backwards, so we're really in the fourth quadrant. Okay, tangent in the fourth quadrant. What's the only thing positive in the fourth quadrant is cosine, and its reciprocal partner secant. So tangent in the fourth quadrant, again, is negative. Lots of negative ratios. Okay, reference angle. The reference angle of negative 60 degrees. Okay, so if I drew that picture, here's the terminal side going backwards 60 degrees, negative 60 degrees. Well, how many degrees does it take to get you back to the x-axis? That's your reference angle, 60 degrees. Always a positive acute angle. Okay, great. Now we have to use this special right triangle. Tangent of 60 degrees. Here's 60. Tangent is opposite over adjacent. So we have the ratio of square root of 3 over 1. Or in other words, square root of 3. Don't box it till you check the sign. It's negative. Okay? Moving along. Cosecant, 315. First of all, check quadrant. 315 is in the fourth quadrant. Okay? Cosecant in the fourth quadrant. Cosecant is going to be negative because the only thing that's positive in the fourth quadrant is cosine and its reciprocal partner secant. So again, we've got another negative ratio. Okay, reference angle. How many degrees is it between 315 and back to the x-axis? Well, if you do your scratch work over here, 360 minus 315 gives us a reference angle of 45. Okay, so let's check our 45, 45, 90 triangle to get our ratio. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is going to be hypotenuse over opposite. So we've got opposite over hypotenuse, hypotenuse over opposite. So our ratio is square root of 2 over 1, or just square root of 2, but don't box it till you look up here. It's negative, because we're in the fourth quadrant. Okay, negative 240, negative 90, negative 180, negative 240. We are in the second quadrant. And oh my gosh, again, cosine is negative in the second quadrant, because the only thing is positive is sine, and its reciprocal partner cosecant. Okay, negative 240. What would that one look like? So if I drew that, here's negative 240. Getting back to the x-axis, we have a reference angle of 60 degrees. Great. Okay, so now I'm talking cosine of 60. Cosine is adjacent over hypotenuse. Whoops, sorry. Adjacent over hypotenuse. 60 adjacent over hypotenuse. I have a ratio of 1/2. Before you box it, look at the sign. It's a negative 1/2. Finally, sorry, I'm going quick here. Cotangent of 210. 210, not positive direction. 90, 180, 210. Third quadrant. And we finally got one. Tangent is positive in the third quadrant, and so is its reciprocal partner cotangent. Positive. Now we got to talk reference angle. If I'm at 210 degrees in the third quadrant, how many degrees refer me back to the closest x-axis? 30 degrees. Okay, now I need to get my ratio by using this little thing. Cotangent would be, okay, tangent is opposite over adjacent, so cotangent is adjacent over opposite. Therefore, 30 degrees, adjacent over opposite, square root of 3 over 1, or just square root of 3 and double check my sign. This one's positive. Okay, again, go back. If you want her to talk, or whoever the sub is, play something back, or it'll be online so you can view it anytime you want this weekend. If you want to go back and watch me listen or talk about anything about this, so you get a worksheet. On Monday, we'll answer any questions again from 5-2, and we'll answer questions on this. Okay? So the answers to worksheet 2 are also online. Okay. Oh, there's my bell. I'm late for class. Okay. Hope you guys have a good weekend. Okay. Bye.